let's go right into this rule. So we talked a little bit about this before lunch today, so I'm not going to need to do any further explanation of this. We're just going to jot down the rule and then go ahead and start to apply it in this particular problem. So the quotient of powers property says to divide powers with the same base subtract the exponents. And then we'll write a generic rule for this so you can see it actually being applied. If I have a to the m power divided by a to the n, this will become a to the m minus n power. So that's how we're going to see it in an application problem. A couple things to highlight here about our definition of it. Number one, this only works, just like your product property, it's only going to work if you have the same bases. Okay? And number two, the order of subtraction matters. It's always got to be the numerator exponent minus the denominator's exponent. Now, one of the things, excuse me, when we did this problem last year, because yes, you did all of these last year right now, okay? One of the things to consider before writing a final answer and moving on is to ask yourself the question, where are there more factors of a number or variable, on top or bottom? Because that's going to tell you where that number should end when you're done, okay? So real quickly here, like, if I have x to the fifth and this is being divided by x squared, where are there more x's at top or bottom? So there shouldn't be a fraction in this problem. My variable should just be on the top. But if I gave you y to the 7th over y to the 13th, where are there more y's at? So when I do my subtraction, it's going to cause me to get a negative number. That means my variable is going to need to be on the bottom. So you should be able to, before you do any computational work, you should be able to determine where your variable is going to end up just by looking at the original problem, okay? So that's something that we talked a lot about last year, making sure that your answer matches what you think that it should, okay? So I'm going to bring that up anytime we do problems like these examples here. So where are there more 7's at, on top or bottom? There's more on the top. So when I get done here, I should have a 7 on the top, and its exponent should be positive, okay? So again, same bases. Those are being divided, so we're going to subtract our exponents. It's the top exponent minus the bottom exponent. So this would be 7 to the power of 13 minus 8, which of course would be equal to 7 to the 5th power. Okay? Where are there more negative 2's at, top or bottom? On the top. So where should my negative 2's end up? They should end up on the top. So this is now going to be negative 2. We do have parentheses. We talked about the importance of that the other day. Okay? And then it's the top exponent minus the bottom exponent. This would now become negative 2 raised to the 4th power. Now again, just to re-emphasize something, negative 2 in parentheses raised to the 4th power is going to give you 16 on your calculator. If you did not have parentheses in that original problem, negative 2 to the 4th power would actually give you a negative 16. You need to make sure that you're aware of that. I would count it wrong because, again, negative 2 to the 4th and the quantity negative 2 to the 4th are going to give me two different answers. Okay? Now, C and D here real quick. Letter C is not just a strict quotient property anymore because we're going to simplify what's on the top first. What's happening to the two variables on the top that are the same base? They're being multiplied. What do we do when we multiply bases? We add our exponents. So the first thing we're going to do is we're going to simplify the top. A cubed times a to the 9th is a to the 12th over a to the 4th. Now, where are there more a's at, top or bottom? On the top, so my a should end up on the top. We're going to take our top exponents and subtract our bottom exponents. So this is going to result in an answer of a to the 8th power. Now, letter D. This one always throws people off. How am I going to use the quotients property? It's not a quotient. Your first step is to make it one. Now, how do we make it one? Well, I can make this second one I can make this into a fraction, couldn't I? How do I multiply? How do I make that into a fraction? No. I put a 1 on the bottom of it. Now, what's the rule for multiplying a fraction by a fraction? Straight across. 1 times y to the 18th is y to the 18th. Y to the 7th times 1 is y to the 7th. So this becomes y to the 18th over y to the 7th. Now you use your quotient property. You take your top exponent and you subtract your bottom. That's going to leave you with y to the 11th. Now, all 4 of these examples resulted in an exponent that was positive, so nothing had to be changed at the end. I just want to caution you, that will not always be the case. Okay, you may end up with a negative exponent, meaning you're going to have to end up moving that entire thing down to the bottom. You may end up with a 0 exponent, which means the entire expression just becomes a 1. Okay, so I'm not forgetting about the zeros and negatives. Right now we're just using the get rid of my like bases idea. Okay, Lily, question? Well, let's just rephrase the question like this, because I don't want you to try to memorize how to do this problem. If I want to multiply a fraction by a whole number, okay, just in general, let's multiply a fraction by a fraction. How do I change a whole number into a fraction? No. How do I put a whole number into a fraction? How do you change 4 into a fraction? Put on the 1 and put a 1 on the bottom. Okay? Then how do I multiply a fraction by a fraction? Multiply straight across. Top times the top and the bottom times the bottom. Okay? I don't want to teach you what to do in this problem here because I want you to know how to multiply a fraction by a whole number. Like if I gave you 5/6 and I asked you to multiply this by 7, okay, what you did there is no different than what you do here. Change 7 into a fraction, put it over 1, multiply straight across. 35 over 6. There I did it. Okay, all we're doing is we're getting rid of the numbers and we're just putting variables into place. I want you to understand the process, not a trick that gets you through that particular problem. So we did this last year, right? We took a fraction times a whole number. I'm doing the same thing here. Taking a fraction, multiplying it by a whole number. Okay? All right. So I told you we had 2 rules today. That's the first one. And I told you one of them was review. It was that one. The next one's not going to be a leap too much farther along the way, though, because you've already seen this. But we called it the power of a product problem. Okay? So real quickly, kind of recapping what we've already done. The power of a product property said that if I had 3x squared cubed, we did this as part of our openers today, what are you doing with this exponent of 3? You're distributing it through to each of these, right? So this ultimately became 27x to the 6th power. Okay? Same idea as this one, except we're going to change the product into a quotient. You're looking at the power of a quotient property for this one. Again, I'm going to spell it out in words first, and then I'll get an example in a picture problem, or sorry, with the variables next. So, to find the power of a quotient, Find the power of the numerator and denominator and then divide. Okay, so here's going to be my example for this one. If we gave you x to the m over y to the n. Okay, these don't need to be same bases, but I've got a quotient that is being taken to a power. Just like your power of a product, you distribute through your exponent. Power of a quotient, you distribute through your exponent. So this will become x to the m times p power on the top, and on the bottom, y to the n times p power on the bottom. Make sure that that gets distributed to every piece of your fraction. Numbers, numbers, variables, any of those things. Okay? So in letter A here, okay, let's take a quick look. And actually, letter A is a problem we've been doing for quite some time, ladies and gentlemen, but now we get to use a new property to come up with this. This squared is going to be distributed to each piece of this fraction. So the top of this is going to become a 3 squared, and the bottom of it will become a 5 squared. And then we're going to evaluate. What's 3 squared? It's 9. What's 5 squared? 25. Now, this shouldn't shock us that this is our answer. If I flip back to an algebra, to our pre-algebra book from last year, this is actually a problem we did in Unit 2. You might say, well, I don't remember doing that. Well, we did. What's it mean to square something? To multiply by itself. So last year what we taught you to do was this. You're going to rewrite this as 3/5 times 3/5. And what's the rule for multiplying a fraction by a fraction? Multiply straight across. What's 3 times 3? 9. What's 5 times 5? There you go. We did this last year. Why would we say, well, why would we say not just come back to this? Because what if this isn't a squared? What if that's a 7th power? I don't want to have to write that out 7 times. That's why we want this property. This property is meant to condense all of the work that we would otherwise do. Okay? All right. Letter B. This cubed gets distributed to the portion that's on the top and the portion that's on the bottom. So on the top, you're going to have a 4 to the 3rd power. And on the bottom, you're going to have a p to the 3rd power. We are going to ask you to evaluate. So what is 4 to the 3rd power? It is equal to 64. And p to the 3rd power stays as p to the 3rd. Now again, I want you to remember, if there would be a negative exponent or a 0 exponent, we've obviously got to fix that. I'm right now focused on using our new quotient properties. But I do not want us to forget about the 0 and negative rules that also apply. Okay? And then as we slide down here to C and D. Now there's no evaluating calculator purpose goes, but we should be able to do a power of a quotient problem where all we have is variables. So on the top, we have an x to the 4th. On the bottom, we have a y to the 3rd. Each of these should be taken to the 5th power. Now, what I've seen from most of you is you're able to skip the step that I'm going to show you, but just so, again, your notes should be something you go back and learn from, not just something that we do busy work for. Technically, what we're doing on the top is we're taking x to the 4th and raising it to the 5th, right? And on the bottom, you're taking y to the third, and then you're raising that to the fifth. Okay? What do we do when we have that power raised to a power? We multiply. So on the top, we're going to have x to the what? 20th. And on the bottom, we're going to have y to the 15th. All right, can I simplify that and get an exponent of a 5? No, why not? Bases aren't the same. I'm not using my quotient property here. I'm using my power of a quotient property, but I'm not subtracting those exponents because those exponents don't come from the same basis. Now, again, do you need to show this middle step here? I'm okay with you not, as long as you're able to get to the right answer. If you're struggling going from here to here, though, show more work in the middle. Okay? This one, we're going to square what's on top, we're going to square what's on the bottom. This one I'm going to show a little bit less work. What's a squared squared? A to the 4th. What's b to the 7th squared? B to the 14th. Okay, is that expression simplified? There we go. No zero exponents, no negative exponents, no like bases. There is the final answer. All right, now, what if we have more than just a numerator and denominator with just a single term? Okay? What if we have problems where my numerator and denominators are products? Okay? So, here's what I want you to be able to realize. How many different things, I can't even call them terms because there's no addition or subtraction. How many different things are on the top of this fraction? 2. There's a 2 and there's an x. How many different things are on the bottom? 2. There's a 5 and a y. All 4 of those things, 2 on top, 2 on bottom, are going to need to be squared. So this squared that's out here goes to 4 different things in here. All 4 of them. So again, I'm not going to do this every time, but you'll see it here. I have 2 to the 1st being squared. I have x cubed being squared on the top. I have 5 to the 1st being squared, and y squared being squared on the bottom. So everybody see how I've broken that up into those 4 individual pieces? Okay. So now, Evan, you with us? Okay. Because I haven't seen your pencil move in a while. And I'd venture to say by looking at your notes, you're not even on the back page yet. What do we do with the power raised to a power? We multiply. So this now becomes a 2 squared on the top and an x to the 6th on the top. And I would have a 5 squared on the bottom and a y to the 4th on the bottom. Does that sound right to everybody? And now we're just evaluating. What is 2 squared? 4. X to the 6th over 25 y to the 4th. Do I have any zero, negative, or exponents or like bases? No. Will I starting tomorrow? Absolutely. In fact, tomorrow, to make these problems a little more complex, we're going to get rid of the y and just keep them all as x's. You might say, well, that's easy. You're getting rid of a variable and you're just making them all the same. Well, but if they're all the same, then that's going to violate the rule of no like bases. So there's going to be additional work that goes there. Now, here's another thing that I'm going to point out. What if let's say I had this. Let's say that I had, I'm just going to throw this out as a final answer. I got done and I had this. Can that be reduced? Yes. Not the variables, but your numbers better be. That's another thing to keep in mind. What would I expect you to do with your 4 and 10? Divide them both by 2 and make this a 2x squared on the top and a 5y to the 5th on the bottom. You need to make sure, like, some people will be like, well, you didn't tell us that. Well, I shouldn't have to tell you in Algebra 1 that you need to reduce fractions, right? That's kind of been a standing thing that we've been talking about for, 18 months. All answers should be reduced. Okay, when you take an Algebra 2 test in 2 years, they're not going to say simplify this expression and then list the 17 different ways to simplify it. You need to know how to simplify it. Okay? Alright, how many things are at the top of the second fraction? 2. How many on the bottom?
2.
All of those 4 things need to be squared. Now, I'm going to skip a little work here. I'm going to get a 3 squared here, a k to the what? K to the 4th over a 4 squared on the bottom and a p to the what? P to the 10th. Okay, I don't want this to be a shock when I write down the final answer, so again, I want us to understand, I can't emphasize this enough, because I don't know how many of you guys actually use this, but your notes should be tools that you come back to when you need to refresh your memory. I'm not just going to give you the final answer, I want you to see where this comes from. Now, evaluate. What's 3 squared? 9. K to the 4th over 16 p to the 10th. Do we have like bases?
No.
No. Do we have 0 or negative exponents? There we go. That's it. All right. You guys try C and D. Check your answer with letter C. I got 125 x to the 6th, y to the 12th over z to the 3rd. I do not have any like bases. I do not have any 0 exponents. I do not have any negative exponents. So that should be my final answer. Oh yeah, and by the way, my fraction can't be simplified. Lilith, question. What? 3. Okay, what was the exponent on the original z? Okay, and what's 1 times 3? Alright, this one. Now, question, is my negative 3 in parentheses? Yes, do you think that's going to matter? Yep. And if I forget it, it's going to be wrong. Now you might say, well, Mr. Tompkins, when you rewrote it like that, why didn't you put the 5 in parentheses? Because the 5 is positive. It doesn't matter. If there's negative, I better make it into a parentheses problem. What's negative 3 squared? 9. A to the 10th over 5 squared, which is 25. B to the 6th. Yeah, I do not have any like bases. I do not have any 0 exponents. I do not have any negative exponents. That will be my final answer. Questions? Anyone? Alright. Now, real quickly here, since this is the end of our new material, I thought I would summarize and you have in one spot all rules that apply to exponents. So I'm going to try to take all of the things that we've jotted down and just give an example in each of these using variables. So for our first one, we started the day with a lot of these reviews. X to the 0th power should be equal to 1. Okay, this is the only one that I'm going to put in 2 of these. If I have an x to the negative n, remember that's equal to 1 over x to the n. And the second half of it says if I have 1 over x to the negative n, that becomes just x to the positive n. Now, technically, I'm going to be honest, they mean the same thing, but a lot of students get confused about the one that's on the bottom and the one on the top. Because technically all you're doing is you're taking the reciprocal of each of those. That's all you're doing. Okay? Your product of powers says if I have x to the m times x to the n, this becomes x to the m plus n power. Your quotient, the first one we talked about today, says you can combine these if the bases are being divided, but you can combine the exponents with subtraction. And remember, the order is always important, so it's the top one minus the bottom one. The power of a power property says if I have x to the m all raised to the n power, this becomes x to the m times n. Power to a power, you multiply. Your power of a product means that we've got a multiplication problem like this, then being taken to a new power. That power gets distributed to all parts of that product. And then you have your power of a quotient, which we just reviewed. You have a fraction that is being taken to a power. That exponent gets distributed to both the numerator and denominator of the fraction. Those are the 8 rules that you will need to know for your assessments. And I'm going to be honest, your next assessment is not just going to focus on the bottom 4 that we just learned. Because your 4th and final standard in this unit is apply multiple exponent rules. You will need to know all 8 of these for your assessment, which should be on Monday of next week. Okay?